So let us come back and prepare aldehydes and ketones from alkenes, right? Let us see from alkenes. So the process which we use here is called ozonolysis, right? So I'm going to add or follow this process ozonolysis or ozonolysis. That means I'm going to add ozone around O3 molecule around alkene. So let us see what it is. Basically, let me write the general reaction. So what actually is ozonolysis? If I just speak, addition of O3 or ozone around double bond. Now let me pick up a general alkene. I'm not mentioning anything. Okay, let us write whichever group it is. I'm just generally writing it. Now I'm going to add ozone to this. Yes, how is this going to add? Just observe. You have 3 oxygens, isn't it? The pi bond is going to break. How do you get? You are going to write Cc like this. Now observe carefully. There are 3 oxygens. 1 oxygen, try to add it in the center. 1 more here and 1 more here. 1, 2, 3. Done. Now, to this particular thing, if I'm going to introduce zinc, what is the role of zinc? Zinc is a reducing agent. Yes, and even I'm going to add water also. I'll tell you why water. Now, as I said, zinc is a reducing agent. Now, what's going to happen? Take your pen. Just exactly cleave this bond here. Again, cleave this bond here. Correct? You're going to get 2 carbonyl groups. How do you get? You get C double bond O. Yes. Now one more is here. This is C double bond O. 2 carbonyl groups. Okay, I've written this here. I'll write in this way only. 2 carbonyl groups. What is left out? Oxygen. So this becomes hydrogen peroxide. H2O2. Done. Now let me explain what I've written in the general formula. Suppose if I take an example 1. Okay, I'll pick up 3 examples. One is, let me take ethene. Let me take 2 butene. And I'll write one more. Okay, I'll just write 2 methyl 2 butene. Let us write for all the 3 and see. Okay, yes. Now let me write for ethene. So ethene molecule we very well know, C double bond C, isn't it? So 1 2. So it is H hydrogen H. Now I have to prepare an aldehyde from this. Let us see we are getting aldehydes or ketones. Now I'm going to add ozone to this. Where does it go? It's going to break the bond here exactly. Now see, this is H hydrogen. Link the oxygen between 2. Yes, this with you're going to break this pi bond and link this oxygen, and you have 2 more oxygens left in ozone. 1 oxygen here, 1 oxygen here. Yes. Now take your pen, cleave the bond exactly here, cleave the bond exactly here. This is going to break into one part, this is going to break into one part. So what do you have now? Just observe. HCHO, formaldehyde. Again, HCHO, formaldehyde. How many moles of formaldehyde? 2 moles you've got, isn't it? So in the presence of zinc, reducing agent, and water, what do you get? You get 2 moles of formaldehyde plus hydrogen peroxide. Simple, just HCHO, right? I've got an aldehyde. So what is this called? Formaldehyde and hydrogen peroxide. Simple conversion of ethene to formaldehyde by ozonolysis. So this is called ozonide. Right? Let us do for 2 butene. 2 butene, observe carefully. I have to write 1, 2. This is butene, isn't it? So this is your second carbon. Yeah, if you start from here, 1, 2, second carbon, butene. Now fill your hydrogens, H3. For this you have H. For this you have H3. This is again you have your H, isn't it? Now to this 2 butene, I'm going to add ozone molecule. When you add ozone molecule, how does this look? It's going to break the bond here. When it's breaking the bond, how does this happen? It looks like C. Now your CH3 is here. Yes or no? Your H is still there. Please, nothing to do with the H, isn't it? We are bothered only about the double bond. Your oxygen links in the center. Again carbon. H is again here. Your CH3. And now what do you do? Okay, I've written H here. You can write your O on the top. Not a problem. Correct. Now, when you're introducing this to in the presence of zinc and water, you're going to cleave the bond back. Exactly, hold your pen, cleave it here and cleave it here. When you're cleaving the bond, what do you get? CH3CHO, acetaldehyde. CH3CHO, acetaldehyde. 2 moles of acetaldehyde. CH3 CHO plus hydrogen peroxide. Hydrogen peroxide. Done. Yes, simple. So what do? We've converted 2-butene to acetaldehyde. Acetaldehyde. Simple. Let us do this. 2-methyl 2-butene. So when I speak about 2-methyl 2-butene, how does this look? Now just observe. 2-methyl 2-butene. Let us write 1, 2, 3, 4. Now this is but, right? So they have 2-butene, so this one. Then they've said 2-methyl also. In the same carbon, I have methyl group also. Correct? Now let's fill the valency. This is 3. Now for this carbon, you have 1, 2, 3, and your fourth one. For this carbon, you have CH3. So now observe 1, 2, 3, 2. That is 4-butene, 2-methyl 2-butene. Now my formula is correct. So I'm going to write, I'm going to add ozone to this. Where does this go and add? It's going to break the bond here, and I'm going to get CH3. Yes, now your CH is there only. Yeah, and your oxygen is going to link both, and your carbon, and you have again your methyl group and one more methyl group here, and you should also add oxygen here and oxygen here. Correct? Now I have to further convert. I'm going to add zinc and water. Correct? So what happens is the bond is going to cleave here and the bond is going to cleave here. Careful now. What are you going to get? You're going to get CH3CHO, one acetaldehyde molecule, and one more CH3COCH3 ketone. Now we have prepared ketone plus hydrogen peroxide. Now observe carefully. Once again, when you are taking here, only one logic you have to remember. Around your double bond, if there is hydrogen, just observe, around the double bond, if there is hydrogen, you get an aldehyde. Correct? Around the double bond, if there is no hydrogen, now this doesn't have hydrogen, but this has hydrogen. So whichever has hydrogen, that will become aldehyde. Whichever doesn't have hydrogen will become a ketone. So this is the ozonolysis process. Once again, adding ozone around double bond, correct? You get an ozonide. After ozonide, you're going to introduce a reducing agent, zinc, right, in the presence of water. So finally what happens? You're going to cleave, hold your pen, just keep that oxygen in the center on either side, cleave it here and cleave it here. So what do you get? One carbonyl group, one more carbonyl group. That is general formula. After that, suppose in the exam, if they give you a compound in an alkene with hydrogens, if you have both on card around the double bond, if you have hydrogens, right, not a problem. Now in this case, what happened? You have hydrogen on this particular side. When I cleave it, HCHO, HCHO, HCHO. Both the sides have got formaldehyde, but here observe carefully, around the double bond you have hydrogens around carbon, so you have got acetaldehyde. But in this case, around the double bond there is no hydrogen for this carbon, so the carbon which doesn't have hydrogen forms a ketone.